Okay, so our function notation, little mini unit here, is just kind of a reminder for most of you as far as what function notation can look like. So we're going to look at 3 different things. We're going to look at it from an equation, from a graph, and from a table, and then we'll also do a few compositions, which could be from any of those. So the first one, what you're probably most familiar with, would be the equations. We've got 3 functions given. Our notation, f of x, remember that's the same thing if you want to think of it as y, but we use the function notation. And then we got g of x and h of x. Here is what we are trying to find. If we want to find g of 10, well, if you look, 10 replaced the x here, so that means that we're going to replace every x. So if there was more than one, you would plug a 10 in anytime you saw an x in your equation. So I'm just going to make this up. Let's say we had k of x was 2x squared minus x plus 10. We would plug in that value for both x's. So g of 10, all we're going to do is we're going to take my g function, 2 instead of a 10 x, we're going to put a 10 minus 3, and then we just solve it out. So 20 minus 3, final answer would be 17. F of negative 1, you find your f function, which is right here. It's just a way of identifying. If I had said y equals 3 different times, we wouldn't know what equation we were working with. So the way that we can kind of label them is with our function notation. Negative 1, we're going to plug that in. Remember, you have to keep that in parentheses. It is so important, especially with negatives, because if you just type that in your calculator without parentheses, it's going to give you an answer of 6, when really negative 1 squared is positive 1 plus 7. Your final answer should be 8. So make sure that you do put those parentheses, or just if you're doing it in your head, a negative times a negative is a positive. Then h of m, so m took the place of x, so all we're going to do is replace x with m, and that's it. There's nothing we can do there. Here, a little bit further, we said we want to find x if we know that g of x is equal to 17. Well, g of x is the entire equation. So I'm going to say, I know instead of g of x, I'm going to write what it's equal to. It's equal to 2x minus 3, and I'm going to set that equal to 17. Now I have a linear equation. Add 3, we get 20, divide by 2, x is 10. And if you wanted to double check, just go back up here. If I plug in 10, do I get 17? Yeah, so that means that we did that correctly. If we want to look at composition, so I'll go ahead and do some compositions. We could say a couple different ways. We could say find f of h of 1. So we'll start easy. So then you always start from the innermost function and work your way out. So I'm going to take 1, substitute it for x. So that is all going to become 5 because it's 5 over 1. I have not done anything with the f, so now I want to find f of 5. Well, that's the same thing that we did up here. So that's going to be 5 squared plus 7. What is that? 25 plus 7 is going to give me 32. So that's a composition. We could also do g of f of x, and we're not plugging any numbers in. We're just going to take f of x right here and plug that in wherever I see an x in g. So I would say we've got the 2 right here, not changing. Instead of my x, I'm going to substitute the entire first function, and then we can't forget minus 3. You could distribute, so we could simplify that and say 2x squared plus 14 minus 3, so my final simplified answer, 2x squared plus 11. So a composition does not have to give you a final constant. Then we've got graphs. Let's see if we can move this. So a function is right here. So instead of saying my function is x squared plus 7 or whatever, I have a graph. If I want to find f of 6, you're going to think, okay, well, that was my x value. I'm looking for the y value. So if I know x is 6, what is that y value? Whoops, we don't have a little label. Let's make that 8. I just made that up. So that means that my final answer would be whatever that y value was when x was 6. Here, we are missing the x, we have the y, so we're just going to go the other way. We're going to find when y is 5. There's multiple solutions for this, but I'm just going to take the first one. My first value is when x is 0. Lastly, we can go through and we can do some transformations on graphs. So if we had, I'm just going to sketch this real quick, something like that, and I said this is my graph of f of x, and oops, I'm sorry, and I want to find f of x minus 2, for instance. You had this on your summer assignment. You're just looking at where this value falls. It's in my parentheses, so that's a translation. It's moving horizontally. It's going to actually be going to the right 2. So all you would do is take every point on this graph and just move it right 2 units. So we're going to go right, right, right. This will come over. And all that is a shifted graph with function notation. You could do anything here. You could do f of x minus 4, and that's going to shift the graph down 4 units. You could do negative f of x, and it's going to reflect it over the x-axis. F of negative x is going to reflect it over the y-axis. So any of those still apply. You're just using it in a more general form. And then finally, the tables. We've got x, f of x, let's just say negative 2, negative 1, 0, 1, 2, and we've got 10, 8, 6, 4, 2. So we got a linear. If I wanted to find f of 0, well, that replaced the x. So I'm going to look right here. My actual answer is 6. So using your table, it's the same concept. It's just we're looking with x's and y's, if you want to think of them that way. So whether it's from a graph, an equation, or a table, you're still doing the same thing every time.